explain the different modes of gear failure. Basically, there are two modes of gear tooth failure. They are failure due to static and dynamic load and failure due to surface destruction. On the basis of the principal causes of surface destruction, failure due to surface destruction is further classified as. Now let us discuss about each of them. Failure due to static and dynamic load occurs when the gear tooth fails due to its bending. And gear tooth bends or breaks completely when the total static and dynamic load acting on it is greater than its beam strength. Failure due to static and dynamic load is also known as bending failure. Bending failure can be avoided by adjusting the design parameters of the gear tooth in such a way that its beam strength is greater than the total static and dynamic load acting on the tooth. Gear tooth failure due to abrasive wear occurs when any foreign particles such as dirt, rust, metallic debris, etc. Note that present in the lubricant enters between the teeth and damages them. Abrasive wear can be avoided by providing filters for the lubricating oil or by using a lubricating oil of high viscosity. Gear tooth failure due to corrosive wear occurs when the corrosive elements such as extreme pressure additives, foreign particles, etc. Note that present in the lubricant react with the surface of the tooth and corrode it. Corrosive wear can be avoided by adding proper anti-corrosive element in the lubricant and by providing proper enclosure to the gear drive. Gear tooth failure due to pitting occurs when the surface contact stress in the tooth surface is greater than the endurance limit of the tooth material. Note that failure begins with the formation of pits and continues to grow, causing the tooth surface to rupture. Pitting can be avoided by placing a dynamic load whose load is less than the wear strength of the gear tooth between the gear teeth. Gear tooth failure due to scoring occurs when high spots of gear tooth welds and shears alternately due to excessive heat generation between the gear tooth surfaces. Note that excessive heat is generated due to excessive pressure between the gear tooth surfaces, high-speed gear drive, and insufficient supply of lubricant. Scoring can be avoided by adjusting the design parameters of the gear tooth in such a way that there is minimum heat generation between the gear tooth surfaces. Related term is